All right, we're going to start chapter 7 here today. So, day 21, section 7.1. And we're really going to start with a somewhat of a middle school concept. We're going to go back to ratios and then work our way into proportions. So, defining a ratio. A ratio is a comparison of two quantities by division. So when we say division, we're basically thinking of little fractions. So it can be something like A over B, or it can be written as A colon B. There are other ways to write ratios. So let's say if we did 3 over 5, we can say 3 colon 5. We can write it as a decimal, or we can even write it as a percent. Those are all ratios. So the key here is comparing two quantities. So you want to be able to identify those two quantities. So the bonsai cypress tree is a small version of a full-size tree. A Florida cypress tree, called a senator, stands 118 feet tall. So the senator stands 118 feet tall. And we can see here that the, let's get a different color here. The bonsai tree is only 15 inches tall. So they give one of the pieces of information here. The other one's over here in the diagram. So just keep your eyes open for where we're getting these two quantities. So we have to read the wording here. What is the ratio of the height of the bonsai to the height of the senator? So bonsai to the height of the senator. That means that bonsai has to go on top and the senator has to go on the bottom. So our ratio is going to be 15 inches to 118 feet. And you can simplify that down if it does. And it doesn't simplify down any further. Now be careful, sometimes if it's a multiple choice question, you might have these converted to be the same units. So maybe we take this 118 feet and times it by 12 inches per foot. So we can convert that to 15 inches to 1,416 inches. So the bonsai tree is 18 inches wide and stands 2 feet tall. What is the ratio of the width to the height? So that means we are going to have wide on top and how high on the bottom. And it does matter. We have to pay attention to the wording there. So 18 inches for every 2 feet of height, or 18 inches for every 24 inches of height, or 2 feet of height is going to give us 1.5 feet. 18 inches is a foot and a half. All right, members of the school band are buying pots and tulips and pots of daffodils. I think it's supposed to say pots of tulips and pots of daffodils to sell at their fundraiser. They plan to buy 120 pots. The ratio is going to be the number of tulips. So that means 2 represents tulips. Daffodils is represented by 3. So a 2 to 3 ratio. How many pots of each type of flower should they buy? So one possibility is to say, if they buy 2 pots of tulips, they buy 3 pots of daffodils. But that doesn't add up to 120. So maybe we double that and we say 4 over 6. Well, that only adds up to 10. Maybe we triple it, or maybe we multiply it by 10. Whatever we do to the top, we have to do to the bottom. So I doubled the top and bottom. I can multiply the top and bottom by 10, but I have to do it consistently to make these the same ratios. So the question we're saying is, what are we going to multiply 2 by? We have to multiply 3 by the same thing so that 2x plus 3y, 2x plus 3x, not y, equals 120. So that's 5x equals 120. So x is 24. So if x is 24, that means we're going to go 2 times 24, and we're going to do 3 times 24. So they will buy 48 pots of tulips and 72 pots of daffodils. And that should add up to 120. And it does. So we're going to continue that theme of trying to figure out what are we going to scale this ratio up by that's going to be similar on the numerator and the denominator. So the measures of 2 supplementary angles have a ratio that is 1 to 4. What are the measures of the 2 angles? Now, supplementary has a hidden total in it of 180 degrees. So that's 1x over 4x. So that's 1 over 4. Maybe that's 2 over 8. Maybe that's 10 over 40. Maybe it's 100 over 400. What is this x value that's going to turn this 1/4 into an equivalent fraction so that when we add them up, they equal 180? X is 36. And that means that the two angles are 36 degrees and 36 times 4, 144 degrees. An extended ratio compares 3 or more quantities. So the lengths of the sides of a triangle are in the extended ratios 3, 5, 6. So maybe the sides are 3, 5, 6. But now they're telling us that the perimeter of the triangle is 98. So that means 3x plus 5x plus 6x equals 98. So adding those up, they're all like terms. Just solving for x real quick. X equals 7. So what is the length of the longest side? The longest side is obviously going to be the one represented in blue here, which is 6 times 7, which equals 42 inches. All right, next one done the same way here. We have red, green, blue. 4x plus 7x plus 9x equals 60. So 20x equals 60. So x equals 3. What are the lengths of each side? So we have 4 times 3, which equals 12. We have 7 times 3, which equals 21. We have 9 times 3, which equals 27. And you can check them. They should add up to 60. Here we have 33. 33 and 27 is 60. And then cross products. This should take you back to middle school, which the idea is if we have two ratios that we know are equal to each other, then A over B, C over D, then if we do a product going across this way, I'm going to go green, That means that BC, that product, is going to equal this product. Now, a couple of things, I don't want you to overcomplicate it. It doesn't matter which direction I do first. It doesn't matter if the yellow was over here and the green was over here. So just real quick here, 5x equals 24. Divide both sides by 5. So x equals 4.8. So be careful on this one. We do have a binomial in this numerator. I'm going to say go ahead and put parentheses around that. So here you're going to have 9y equals 3 times y plus 4. Which is going to then trigger you to use the distributive property. So 9y equals 3y plus 12. 6y equals 12. Y equals 2. Try again. I think this here is a little bit of a mistake. Let's ignore that. 2a equals 9 times 14, which is 126. Divide both sides by 2. A equals 63. Down here, I immediately put my parentheses. 15m equals 3 times m plus 1. So that's 15m equals 3m plus 3. Subtract 3m from both sides. Divide both sides by 12. M is 1/4 or 0.25. Sorry, my iPad froze there. There we go. All right, and then to finish off, it's just important here to understand that we can write a proportion essentially 4 different ways. So if I set something up like A over B, C over D, it's okay to flip both of these fractions. If I have something like A over B, C over D, it's okay to basically write it horizontally. A over C, B over D. And then this third way here is if I add these two together, so A plus B all over B equals C plus D all over D. And then here we have some actual numbers to kind of look at that. So 2/3 and 4 over 6 is the same as if we flip it, 3 over 2, 6 over 4. 2 over 3, 4 over 6. Basically, it's 2 over 4, 3 over 6. Then here, 2 plus 3 over 3, 4 plus 6 over 6. So 5 over 3, 10 over 6. All right, so we want to use that idea in order to write equivalent proportions. So in the diagram, x over 6 equals y over 7. So now if we look down here, x is now over y. So that means right here, we're going to put 6 over 7. So what they did right here is they used this property up here. And it makes sense if you look over here at the two triangles. So up here, what we said was x over 6, y over 7. Think about corresponding parts. And then down here, we did x over y, 6 over 7. This is actually a good way to make this have some more of a visual effect. X plus 6 is this whole side of the triangle. So when we add those together, x plus 6 over 6, which is the corresponding side of the smaller triangle, y plus 7 over 7, if we think about two separate triangles. All right, x over 6, y over 7. Now we have 6 over x. So it looks like they flipped that, so we better flip the other side and do 7 over y. All right, take a look at the homework. Take your time on that. Ask me any questions. Email me, message me through the Google chat, virtual office hours. Don't forget about the live reviews that we have. There will be a quiz this week or this unit. And just make sure you guys are staying in contact with me if you need any help, whether it's outside the office hours, more one-on-one. Just make sure you're staying in touch and communicating with me.